Hello? Yo, what's up, guys? Welcome back. I hope this is all working. We're gonna be programming every day today, so hang on, let me just make sure everything's working. Okay, I think it's all on. I think it's all good, but yeah, hopefully this will be a little different. Maybe like programming live. I'm not sure. It's my first time ever really streaming, so I don't really know what I'm doing, but you know, it should be fun today, and we're gonna pump out a few problems. So, oh, here we go. Let's jump in. Let's check out our daily problem day. Gotta fix my hair here, man. Oh. All right. Looks like we got an easy problem today. Let's take a look at it. Given an integer number. Oh my god, my eye hurts, dude. You know that Bob will sneakily remap one of the 10 possible integers from 0 to 9 to another digit. Return the difference between maximum and minimum values Bob can make by remapping exactly one digit in num. When Bob remaps a digit D1 to another digit D2, Bob replaces all reoccurrences of D1 in num with D2. Okay. Integer num, you know that Bob will sneakily remap one of the 10 possible digits, 0 to 9, to another digit. Return the difference between the maximum and minimum values Bob can make by remapping exactly one digit in num. Okay. When Bob remaps a digit D1 to another digit D2, Bob replaces all occurrences of D1 in num with D2. Oh, yo, what's up, Web Study? What language should I learn first? I only know HTML and CSS. To be honest, bro, I'd probably just start pumping out some Python, dude. Like, not gonna lie. I'd recommend you to jump on this website, just jump on LeetCode and start solving problems. You know, just start learning and, you know, use the internet to your advantage to, you know, solve the problems and just learn. So, but I definitely recommend Python. It's probably the easiest one to pick up. Bob can remap a digit to itself, in which case the num does not change. I'm a little confused what's going on here. Let's take a look here, though. To achieve the maximum value, Bob can remap the digit 1 to the digit 9 to yield 99899. Bob can remap the digit 1 to the digit 9 to yield. Okay. To achieve the minimum value, Bob can remap the digit 1 to the digit 0, yielding 890. Damn, I may as well start learning Python. Any good places to learn except LeetCode? To be honest, man, I would probably just jump on like a some sort of like Udemy course or something, or maybe, you know, even just check out some, you know, you can jump on YouTube and check out Python courses too on YouTube. Some of them are like crazy long, like 10 hours long. I don't really think you need to like go like super in depth into learning Python like that. I think you can just do like a basic like introductory course just to like get yourself into Python, and then I would literally just start like trying to make projects, or jumping on leak code. Jumping on leak code and doing things like that. It actually comes along pretty quick. You'd be surprised. I mean, you start doing some problems, like you're really gonna struggle for like the first couple months, but once you jump into it and start doing it, it gets better and it comes faster. So definitely recommend doing that. So I gotta. Bob can remap a digit to itself, in which case num does not change. Bob can remap a digit to itself. Okay, so what are we remapping it to? Bob replaces all characters D1 in num with D2. Oh, we given? No? Okay. Bob can remap a digit to itself, in which case num does not change. Bob can remap different digits for obtaining minimum and maximum values respectively. The resulting number after remapping can contain leading zeros. To achieve the maximum value, Bob can remap the digit 1 to 9. Okay. Return the difference between the maximum and minimum values Bob can make by remapping exactly one digit in num. Cyclically remap one of the 10 possible digits, 0 to 9, to another digit. Return the difference between the maximum and minimum values Bob can make. This is interesting. To achieve the minimum value, Bob can remap the digit 1 to the digit 0, yielding 890. Okay. Yeah, bro. All good, man. I definitely just recommend just jumping into it, dude. Seriously. Just, I feel like the hardest part about learning anything is just starting. Just jump in and just get into it, bro. Like, that's what I definitely recommend. Try to remap the first non-9 digit to 9 to obtain the maximum. Non-0 digit to 0. I'm a little confused with this problem. I'm not gonna lie, but we're gonna start. So we're gonna do a basic for loop here. We're gonna need the index, so that's why I'm using the range function with length nums. I'm trying to think here. I'm trying to think here. Really, do we need like a hash map or anything? It's just a greedy algorithm. Okay. Because really, I think we're just changing the most reoccurring number. So I feel like the number that reoccurs the most, we change that to 9. Or is it always the first number? I guess it would always be the first number, right? Because to make the maximum number, you'd have to change the first number to whatever it is, right? Because if you make this 9, but this is 8, 9's always going to be higher. So I think what we want to do here is we want to find out what our first number is. So we would do, okay, well, let's do first num is equal to num 0. I guess it's an integer, so we're going to have to convert this to a string, I think. Dude. Let's print our first num. It's not subscriptable. Oh, jeez. Num 0. Oh man, what is going on here? String num is equal to string num, and then we can do first num is equal to, I guess it's not an array, right? Guess we'd have to make it a list. What am I doing? I think this has to be a list. We make first num is equal to string num 0, right? I think this should work now. Now we print our first num. It's not iterable. What are we doing here, bro? What is going on here? List string num. List string num. First num is equal to string num. Print first num. There we go. Finally. Okay, so we get 1 here, right? So we know what our number is, right? So now we can loop for I in range length nums, right? We can just simply do, okay, well, if num 0, sorry, if, I guess this would be, I think it's string num. If string num I is equal to first num, right? Then we know that we want to change it, right? So here we can find our maximum number, find our max, right? We can do if string I is equal to first num. We make string num I equal to, I guess we can actually, this can be our max. We can do another one for our min. Right, just grab this, make this our min. Get rid of this print now. String num. Let's do min string num. Min string num. We can do I mean, there's so much of a better way to do this, but this is like a stupid way that I'm doing it. Let's do max, make this min. Min string num 0. Find out max. I think we need a max string num here as well. Let's jump through. If string num I is equal to first num. Max if is equal to max first num. And max string num I is equal to string num is equal to 9. Okay. Else we don't do anything. Then what are we doing? We want to do the difference, right? So we want to save this. So let's print our max string num. Take a look what we're looking at here. String num is not defined. Whoops, is equal to max string num right here. String num is not defined. Okay, sweet, that worked. Okay. Now we can find our min here, right? It's probably so much faster way to do this, but that's right. As long as you're getting the problem done, I feel like that's all that matters. Max string num, if min string num I is equal to min first num, then we would want to make min first num, min string num, and all these variables are named the same, dude, is equal to 0, right? Now we have to remove the zeros from min, right? Because if we were to print this, print our min string num, we're gonna get min string num. This needs to be a capital here. Okay, we got the zeros. Now we need to remove the leading zeros, right? So to remove the leading zeros, how can we do this? We can loop through for I in min string num. If let's make this num. If num is equal to 0, we could just slice it technically, but I'm trying to think. We could probably just slice this, not gonna lie. We could just probably remove it using the index value too. What do we want to do? And array index value. I guess we can do for num index in enumerate and string num. If num is equal to 0, then we can do delete and string num index. Also, if num does not equal 0, we can just break out of this loop. Right? Let's print out min string num. Bro, this is such a bad way to do it. Oh my gosh. Do this problem. Eight, 9. Why is it not going through the whole way? What is going on here? Hang on. Remove leading zeros. Min string num. Oh shit, I'm unpacking this in the wrong order. Whoops, index num. My bad. Whoops. Nope. I'm unpacking it in the wrong order. If num is equal to 0, delete. Modifying the list while iterating over it. Yeah, jeez. Okay, yeah, that's why. Well, that was stupid of me. Well, min string num. Min string num. 0 is equal to 0. Oop, whoops. I'm gonna delete and string num 0. There we go. Okay, so we're deleting the first element here until it's no longer 0. That's simple. Oh, did I just do there? Okay. So now we can simply just return The difference between, so it would be int max string num minus int min string num. Oh man, that was really not worth. Int argument must be a string, a bytecode integer number, not list. Must be a string. What? We're returning an integer though. I don't know if it's something inside the return statement, maybe. Int argument must be a string. Why? String's not gonna do anything here. Yeah, what? Hey, we're gonna have to maybe convert this into a string and then into a I appreciate it, Omar, dude. Appreciate it, dude. Thanks for the support, dude. Trying to think here. I think I'm gonna make this into a string or something. Yeah, man, this is such a terrible setup, literally. So use a string num string res2 is equal to string max string num. Oh. Let's get rid of this return statement here. Print string res1, print string res2. Yeah, I know the return type is int. I don't know like what's going on here. Like, I've got into a list, but I can't, simply return it. Like, make it in, like, cast it into an integer, min string max, or whatever I called it. I think it was. Man, I've got so much bullshit going on here. Like, what did I call it up here? Min string num. I can't cast this into an integer because it doesn't like it. And I don't know. This has to be max here. Look, I'll show you guys the return error. Like, I don't know. I literally have no idea why this isn't like. Like, it must be a string. Bytes like object, a real number, not a list. Do I have to go? I'm just gonna copy this error, dude. Yeah. I don't know. Yeah, Omar, I don't know. I'm gonna figure it out. I'm just gonna put it in the internet and figure out what the hell's going on here. Oh, okay. Okay. I think I have to do. Man, this problem is literally all over the place. Like, let's do this dot join string num. Let's do res2. This is what I gotta do. I don't know how I didn't think about this earlier, but it's right. And then we can just return res2 minus res. This is it's such a sloppy, is this expected string instance int found? Item 2 expected. 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 2 Man, what is going on here, bro? What is my issue, bro? Tell me. Gonna make this into a string here. Oh my gosh, dude. That literal fan with base 10. Man, this is so... If in min string num is else 0. If min string num else 0. Yeah. Man, this problem's messing me up, dude. I hate greedy problems. Man, I don't know how to solve what I'm doing wrong here. Does anyone know, like, anyone got a solution for me what I'm doing wrong here? I don't know. I feel like I'm close, but I'm just like messing up something. Digit to be replaced is always the first digit. Okay, which is not necessarily optimal. Replacing the first digit in num with 9 to get the max. Okay, I thought that would be the greedy part of it, but you remap all occurrences of one chosen digit to another digit 0 to 9, keeping all the other digits the same. You must choose one digit to remap. Always replacing the first digit. Code with C, bro. Yeah, can't do it. Can't do dot join on int. Yeah, I know. I'm not doing it on the integer. I think I'm doing it on the list, bro. It's a list of strings. Code in C, bro. I don't think I've ever coded in C in my life, bro. Honestly. Yeah, appreciate it, Omar. I think I'm close. From what the internet's telling me is that I'm not. Well, what GPT's telling me is that I'm thinking about the greedy part in the wrong way. Like, I thought about, looking at this problem. I thought the greedy part of this problem would be, we'll replace, every single first number here to make it the maximum. You always replace the first number to make it a 9 to make the maximum, right? But then to do the minimum, you just pretty much got to do the opposite and replace it with a 0 instead. But obviously that wasn't the right way to think about it. Keeping all other digits in the same. Placing the first digit so you may miss better replacements. I don't know, how the hell is there a better replacement? I didn't think there was. There's always. If you're not able to solve it, ask GeForce. Would have folded as a baby as ass and hole. Nice, bro. What a cool comment. Instead of trying all digits, you can, for max, find the first digit that is not 9 and remap all of it to 9. For the min, find the first digit that is not 0 or 1 and remap all of it to 0. Okay. So I think my issue is I'm always mapping it here to the first number, right? So what I got to do is I got to find out max for I and range length, max string num, if max string num I is equal. So we're just looping here, doing this. Can you just fix my code? Okay, so instead of doing this, right, we want to find our min, find our max, get rid of this, get rid of this. Okay, find our max, right? So we want our max target is equal to 0, right? First digit that's not 9 through. Okay, so I guess we can just make this here. So we can do for num in let's get rid of this. So convert, let's get rid of the comments, right? We go here to find our max. We do max target is equal to none for num in num string, right? If num does not equal 9, then the first number that's not 9 is the first. 9, then we make the max target equal to 9, and we would break, right? Okay, that should be good. Then what we want to do is we want to go, well, our min target is equal to none for num in num string. If num does not equal you want every element that's not 1, I think. So every element that's not 0 or 1. So if num does not equal 0 and num does not equal 1, we can make our min target equal to num, right? And then we can break. Okay. So then now what we want to do is we want to flip here, right? So we would go, okay, well, for I in range length num string, okay, we flip each value to 9, right? So if num string I guess we would do, let's do max list is equal to num string. Guess we can do max list here. If num string I, sorry, we want max list I is equal to max target, then we want to make, oh sorry, equal. We want equal to max target. Then we want to flip it around. We would do max list I max list I is equal to 9, right? We want to flip it to 9 because we want the maximum. Okay, I think that's good. Why is this light blue? Okay, I'm gonna leave that. I don't know why that's light blue. It looks a little weird to me, but alright. I guess we can just copy this, right? Put this here. Instead, we can make this min list is equal to num string. Move through, we go min list. We do, well, if min list I is equal to min target, we make it 0. That should be good. Then we want to remove the zeros from min list. Come here, remove the zeros while min list. Okay, this removes while min, so you know, while there's something in min list and min list 0 is 0, then we delete min list 0. So it's literally just deleting the first value constantly over and over and over again, right? Then we can join it all and return it. Let's see what this gives us. Man, in range, we're missing a parenthesis here, which means we'll be missing a parenthesis over here as well. Min string num is not defined. Let's do min list. If min string num, min list, else 0, return. Oh shit, whoops, min string num, this is min list. This is min list, this is max list. Min string num, min list. Man, I hate this part of LeetCode, dude. Oh my gosh. Base 10. Eval literal for int with base 10. Let's do res max, res min, just so we can see this better. Yeah, no, I agree, bro. I agree. I just, to be honest, I didn't really expect this problem to be, for me to have so much trouble with this problem. I was literally just going to kind of wing it, but usually in the other ones I do, but this one, usually with the easy problems, I usually don't even whiteboard anything, so res max. This problem is just kind of has a tricky part to it. I don't know why I'm getting this error here. So what is your approach to solve the problem? Well, my approach to solve the problem is, I mean, I can jump up. Hang on. I can show you. Yeah, this is what I'm looking for. Okay. Right, so we look here. I think I've nearly solved the problem. I just got some little issue here, right? So look at this problem. Pretty much what we're doing in this problem is we're returning the difference between the maximum and minimum values Bob can make by remapping exactly, you know, one number or whatever, right? So we have our initial number here, 1891. What we want to do in this problem is we want to pick a number and find the maximum of this number, right? So the maximum of this number is 9, right? So we'd flip all our ones here. Sorry, man, my handwriting on the computer is so bad. We flip all these to 9, right? Or what is this number? This is a 9 here. 9, 9, right? So this would be our maximum number here, okay? Right? And then what we want to do is we want to do the same. We want to get the minimum, right? So the minimum here would be 0, 0, 8, 9, 1. Oh, sorry. My bad. There'd be a 0 here as well, right? So that's pretty much what we want to do. And then what we want to do is we want to get rid of these zeros, and we want to do what we had before. So our maximum here, which was 99899 minus 890, right? Do a minus here, okay? So my idea is here is we want to loop through this value here, 9989, right? We want to loop through it, change, as long as the number is not 9, the first number is not 9, we want to change the next number after it, right? So we make it, so therefore it makes it at the max every time, right? And we do the same for the minimum. Oh shit, someone's calling me. We do the same for the minimum, and then obviously with the leading zeros here, we use this function over here to remove the leading zeros, not the function, this for loop here to remove the leading zeros. Oh wait, no, it's right here, right? But the issue I'm getting here is that, you know, so we find our max here, right? We loop through the original string. If it's not equal to 9, we make our max target. Oh, what did I do here? Max target is equal to. This is where I'm messing up here. Max target is equal to num. Well, that might have helped. That could be my issue right there. Is that why I'm not? Okay, never mind. Yeah, so if our max target is not 9, we make our max target equal to num, right? And then we flip it. We flip all our values, what I was talking about, right? We find our minimum. So this is where we find our minimum, value. We flip it, and we remove the leading zeros. And then this is where I'm joining it from a list with strings in it into an integer with strings in it. But I don't know why I'm getting this. Why I'm getting this error here. I have literally no idea why I'm getting this error here. And to be honest, I don't even know what this means. So if anyone could help me with this error, I would appreciate it, because I think that's because you're trying to convert an empty string into an integer. Okay, so if min list else 0. If anyone knows why min list, oh whoops, this is for this one here. Min list is not defined. What do you mean min list? Oh, forgot capitalization here. Man, I've been on this problem for 45 minutes, dude. This is insane. Base 10, we're doing the same thing here. If our literal for int with base 10. But this should never be 0. Man, what is going on here? Okay, I'm not sure. I'm gonna get help from GPT. I don't know what my issue is here. You did this, okay. You mistakenly modifying max list again. Oh shit. Where am I flipping it wrong somewhere? Find our min. Oh, this is my issue here. There you go. I would have not seen this min list I. Right, I'm doing that right now. So that's my issue. Okay, we're still getting it there. Let's do a dot copy here. Oh, we're returning something now. Okay. So passing this test case, but we're not passing this one in. We're getting 8808, but we want 9909. What if we get rid of this? Oh my gosh, dude. What am I missing here? Bro. This pissed me off, dude. I don't know what is wrong with my stuff. You can add a simple check. These are terrible test cases, though. I'm not gonna lie. Oh man, this problem is so pissed me off, dude. But I don't want to skip it. I want to finish it. Okay, I'm gonna look at a solution, dude, because I don't understand how I'm getting this wrong. Or is this literally what I'm doing? Except mine is like way more code than it needs to be. S is equal to string num. Max S is equal to S. For CH and S. CH9 does not equal 9. Max S is equal to S dot replace. Break. Bro, so what is the difference between... This is literally what I'm doing. What am I missing here, bro? Let me print. This max is not found. 99899111091. What? Something wrong with my finding the min. CH does not equal 0. Num does not equal 0. Min target is equal to num break. This should be... It should be 890. I don't know. Bro, no way. Was that my issue, bro? Dude, there's no shot right now. $99 and 0 though. What should this be? Expected 99. Oh no, that's right. Bro, was that my issue the whole time, dude? No way, bro. Dot join max list. Where's min is equal to int this dot join min list. Okay. If min list else 0, right? Because if it's 0, then we don't want it. We can return our res max minus our res min. Dude, please submit, dude. I want to be done with this, bro. Oh my gosh. Oh my gosh, we did it. In the slowest way possible. I mean, my solution was literally terrible. It didn't have to be as hard, as complicated as I made it, but we got there in the end. So that is all that matters. That was terribly done problem by me. But let's get out of here because I do not want to look at that problem again. That was terrible. Omar, let's go, dude. You're still here. Yeah, man, I solved it. There we go, dude. It was literally one mistake. Tiny mistake. Yeah, bro. Thank you, man. Thank you, Surav. Man, that problem was frustrating, bro. I can tell you that. Let's jump into a graph problem. I do enjoy doing graph problems, so I did look at this one yesterday. I kind of failed at this one. It was tough to kind of think about. So let's jump into number of closed islands. Let's take a look what this is. Given a 2D grid consists of zeros land and ones water. An island is a maximal four-directionally connected group of zeros, and a closed island is an island totally all left, top, right, bottom, surrounded by ones. Turn the number of closed islands. Okay, so we got zeros and ones. An island is a maximal four-directionally connected group of zeros. Four-directionally connected group of zeros, right? So when we're looking here, an island is a maximal four-directionally connected group of zeros. A closed island is an island totally all left, top, right, bottom, surrounded by ones. Number of closed islands. Return the number of closed islands. Okay, connected group of zeros, and a closed island is an island. A closed island is an island totally all left, top, right, bottom, surrounded by ones. Okay, so we're totally surrounded by ones here, so I think this would be 1. I'm a little confused looking at this. Islands in gray are closed because they are completely surrounded by ones, group of ones. 0, 0, 0, 0, 0, 0, 0, 0, 0. Yo, good night, Omar. Appreciate it, dude. Thanks for the support, man. Appreciate you being there for that problem. That was kind of frustrating, but it's alright. Islands in gray are closed because they are completely surrounded by water. Okay, I have to think about how we can solve this because I'm not sure. What I'm getting from this problem is that we're looking for a group of zeros that are completely surrounded by ones, right? So this is 1, right? But and the other one I think is here, right? Because this 0 is completely surrounded by ones, north, south, east, and west, right? So I guess what we want to do here is I think we probably want to run a BFS based on But how would we do that with all of these zeros here? There must be a trick to this. Have any hints? Exclude connected group of zeros on the corners because they are not closed islands. Okay, yeah, so you can totally ignore the zeros over here. So pretty much you're only looking at the zeros in here, right? So I guess somehow if we were to the beginning, I think what we want to do here is we want to loop through here, through this problem, through this grid, sorry, right? Excluding the outer edge here, right? If we see a 0, we want to append it to our queue, right? So we append every single 0, right? That's not an edge, right? We look at this 0 and we check, okay, well, maybe we can have some sort of counter that if we can see, no, that's not going to work. I was going to say we could see some sort of counter that if we see 4 1s, then we know that it's connected. But how can we tell that it's all connected by zeros? Return the number of connected components. Okay, that's a great hit. And return the number of connected components of zeros on the grid. Nice, man. So I'm trying to think here. Maybe if we just ran the 0 here. Okay, I think I have an idea, right? Maybe if we just ran a 0 here, we ran our BFS from here, right? And we go through, as long as we don't hit an edge, right? Then we're going to know that this is a connected component, right? If we don't hit an edge, we can keep a visited array, keep a visited set, right? And this visited set will keep track of all the zeros that we've discovered, right? And if we haven't discovered a 0 yet, right, that begins our BFS, then we can add that as a component. And I think this should solve that problem, right? So I think that's our game plan here, right? So what we want to do is we want to make our rows, right? So we length the rows would be the length of the grid. We do our calls, which would be the length of grid 0. Okay. And what we want to do here is we want to loop through. Okay, so let's do, well, for row in rows, for call range rows, call in range calls, right? We want to check, this is where we check, okay, if grid row call is equal to 0, right? And it's not in, and row call not in visited. Okay, this is where we need to create our visited array, right? We also want to call our from collections import DQ, right? We want to create our queue. If our row call is not in visited, we want to increase our count by 1 because we know, right? We increase our count here by 1 because we know where we are located here in 0, right? We know that if we start here, we loop from here, we know that every single 0 that we discover is going to be part of the island, right? Okay, and as soon as it hits a 1, we don't add it. We don't keep looping, right? So then we know that this is one island, right? And then as we loop through all our zeros, we know, okay, this is discovered, this is discovered, this is discovered, this is 0, and it's discovered, 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 Then we come here and we see that this 0 is still not yet discovered. We know that this is a separate component right here, right? So we come here, we increase our count, and this is where we call our BFS function, right? We call BFS, we want to run BFS on we want our row, our col, we want to incorporate our queue, we want our visited, right? And that's what we want to do here. We want to call this row, col, queue, visited, right? Okay, so here is where we want to add queue.append. We want to append our row and our col, okay? What we want to do here is, okay, now we want to do a while queue here. We want to pop here, right? So we'd pop our row and our col. Oh, we need a directions array. Forgot about that. Let's make our directions array. Let's go up, down, right, left. Right. Now up here would be, if we think about an XY plane, we go, okay, so 0 minus 1 would be, no, up would be, yeah, 0 minus 1 because we go 4, 3, 2, 1, 0. So it'd be minus 1. Our down would be 0, 1. Our left would be, sorry, our right would be positive. Yeah, our right would be positive, and our left would be negative, right? So we can add be negative 0, right? We obviously need to pass in our directions array here, of course. Q.append row col while q, so we want to equal to q.pop left, right? And what do we want to do? We want to loop through here. We want for new row, new col. This is where we look for our separate. Sorry, we're looping through here through this for loop here because we're looking for our new destination, our new part of the grid that we're going to, right? So if we know that this is one connected component, the way that we're going to do the BFS here is that we're going to use this directions array and move according to it, right? We're going to move right, left, right, left, down, and up, right? So we're going to loop through our directions array here. We're going to create our new destination that we're going to, right? Our new row, which is going to be nr plus our original row. Our new col is going to be new col plus our original col. We're going to check. Now we're going to check if it's in bounds here, right? So we're going to do, okay, well, if 0 is less than or equal to new row, right? We want to include 0 in our row, right? Because, we start at 0, right? Make it less than our rows, and 0 is less than or equal to new col, which is less than our cols. Then, okay, we want to check that if it's in visited too, right? So if 0 is less than rows, less than cols, and it's not in visited, and our row col, we want to check in our, what do we call it here? Our grid, row col, we want new row. Let me mess that up. New row, new col does not equal and our new row, new col is equal to 0, right? And our new row, new col, not in visited, right? That was a lot. Okay. If we check if it's not in visited, now what we want to do here is we want to append to our queue, q.append. We want to append our new row and our new col. And then obviously we want to add it to visited, right? Visited, new row, new col. So now that we've done that, we Okay, we've increased our count here. Do we have a count variable? No, I need to make a count variable. We do this, we go for row, for call, if grid row call not visited, count plus equal to 1, BFS row call queue visited. Okay. Oh, we didn't return anything. Whoops. Let's return our row. Oh, we're missing one argument here somewhere. Need to add in our directions down here. Return. We want to return our count. Hopefully this works. My fingers are crossed that this works. I don't know. Hopefully. Okay, so we got 2 here. We got this one to work. Oh shoot! I know what we messed up here. We're adding the edges here. I didn't specify that. I didn't specify this here, so we can't be looping through the edges, right? So, and okay, and row. Okay, let's do it in a separate if here. We can do, well, if row is equal to, we could do it on the same if statement technically, but I'm just going to do it on Chris Nara's brutal. Yeah, bro, it is brutal. Okay, if row is equal to 0, or wait, how are we gonna do this? If row is equal to 0, or row is equal to rows minus 1, or col is equal to 0, or col is equal to cols minus 1, then we know we would tab this over. Rows cols minus 1. So this is saying that it's an edge case, right? So screw it. I don't even want it. Let's just continue, right? And then we can just do an else here. And this should work. It's kind of a stupid way to do it, but I think that let's go, baby. Let's go. Let's go. We solved that shit. We solved that shit, dude. I'm kind of proud of myself on that. I didn't even get any errors. Oh, damn, bro. Oh, no. No, that's brutal. That sucks, dude. I thought I solved it. Damn. Okay, let's look at this test case. That's so frustrating, bro. Oh my gosh, dude. I thought I solved that, man. Ah, dude, man, that sucks. Okay. We're missing something here, so okay, so let's walk through what we're doing, right? So we're looping through each grid. We're checking if the grid is 0, right? Which is what we want, and the row call is not unvisited, then we're checking, okay, well, if we're checking that pretty much it's not an edge, right? We don't want to add edges, right? Because one of our hints was exclude component zeros that are corners because they're not closed island, right? These can't be closed by an island, right? If it's anywhere on the edge, right? So we have a continue here because we're lazy, right? And we're just using the else, so everything else. We're incrementing the count by 1, and then we're adding it to our BFS, right? Yeah, bro. Chris, I'm actually living in the US too, bro. So I know I have an Australian flag over there. I study here in the US. I played college tennis here. I played tennis here in the US, so I'm looking to get a job in the US as well, but I mean, I don't really mind, you know, I'd get a job anywhere, but you know, hopefully something nice, but I appreciate it, bro. Thank you for the Thank you for the love, dude. So it's definitely a grind. I've actually come a long way from where I started, man. When I first started, I literally struggled with like easy problems on here, like whatever. I don't even know. Like I couldn't even reverse a linked list, bro. So so I mean it just comes after practice and stuff, dude. What sort of did you go to like a top school, dude, or were you like at a low tier school? I went to Eastern Illinois over there, so like I mean probably no one here has probably heard of Eastern Illinois, but yeah, it's a very small school, very small Division 1 school. I played tennis there and it was fun. I enjoyed it. So but yeah, bro, might be easier if you went to a bigger school, or but it's whatever. But anyway, where are we at here? I think what I'm getting wrong here is that, okay, well I saw here that we didn't add to our visited set, right? So we need to add what we're currently looking at to our visited set, right? Here we're adding our new row, new call here. Let's see if that fixed it. I don't know. Maybe that was, nope, it didn't fix it. Coming through here, if row is equal to 0, okay, we increase our count. We get our BFS here, BFS row call queue visited directions. We come in here, we append it, we add it to our visited, okay. We go while queue row call is equal to q.pop left, right? We go for nr nc in directions, new row, new call. And we check if it's in bounds, we check if it's 0, and we check that it's not in visited. I feel like we're missing something here because maybe I feel like there should be better test cases, but because maybe this could be a 1 here, right? Technically, and it wouldn't count, right? Technically, if this was a 0 here, right, this wouldn't be enclosed, right? So I guess somehow I feel like what we're missing out here is that we have to check that it's maybe how do I say this? We have to actually check that it's enclosed in the ones. I think that's what we're missing out on here. If we would have, it's hard to, I mean, dude, it's hard to look at this array and kind of visualize the test case, but I went to a decent school, but I only got my job opportunity because of connection. To be honest, that's more important. Yeah, you need the skills, but the opportunity is what matters the most. Appreciate that, bro. What type of programming is this? I mean, or web development or what? I mean, I'll answer both the questions, but Chris, I appreciate that, bro. I try and grind hard on the LinkedIn and everything, and trying to reach out to recruiters, but like it's tough. Like I try to get friends to help me and other people, but it's definitely tough out there, and I'm hoping I can find something because I'm really passionate about programming, and I love sitting on the computer, dude. It's fun. So what type of programming is this? This is just like I don't even know what you call this. Like this is just like kind of brain teaser problems. It's something called lead code. It's for like preparing for job interviews and stuff, practicing like data structure and algorithms. So it's just kind of like fun brain teaser problems, I guess, to help you with all sorts of data structure stuff. The art eclipse, good luck, buddy. I appreciate that, man. Thank you, dude. I hope I know watching someone else program is probably pretty boring, but like I appreciate you guys like stopping in and checking it out. So But let's get back to this problem. I think that's what I'm missing here, though. I feel like I gotta somehow check in here that there's ones here, because this could be a 0, right? How can I do that? I don't know. Is there terrible example images? Number of islands not touching outer boundaries. Number of islands not touching outer boundaries. This guy's literally posted his video in here.
Hey everyone, welcome to my channel.
Oh shit, my headset's not even on. Good luck, man. Your grind will pay off one day soon. Appreciate it, dude. Thank you, man. Thank you for the love, dude. Thank you for that. I'm not even gonna watch this guy's video, dude, to be honest. I don't really want to watch it. Have you checked NeetCode? Have you checked NeetCode website? I think it's sick. Yeah, dude. I've done all these problems. I've done the NeetCode 150. I've solved about like 400 problems, I think, on LeetCode. So I've you know, I wouldn't say I've solved all of them, but I've gone through it. I do struggle with a lot of problems too. Like, you know, I feel like with my level being at like 400 problems, you know, roughly solved, is you know, I understand kind of how to solve the problems. Yeah, bro. Yeah, it helped me a lot too. I kind of understand like kind of how to solve the problems, but sometimes I just don't really know how to like execute it properly, and that's kind of what I'm trying to work on. You know, like, and especially like getting to the hard problems is where like I mean, I guess it depends on the sort of problem you look at, but like if you're looking at a proper hard problem, like I feel like there's a big level difference between, you know, a hard problem and a medium problem. You know, at least. Did you try Kotlin? I have never even looked at Kotlin in my life, Kurt. I've never touched Kotlin. I've only really worked on Python, Java, and, you know, JavaScript and, you know, web development stuff. So you're only checking if the starting point is on the border, but an island can expand to the border even if it starts in the middle. In that case, it's not closed. This logic fails for islands that start away from the edge. Okay, fixed. Track the island touches the edge during BFS. Okay, so my issue is here is that I'm tracking the island here. Yeah, I haven't solved the hard one without help yet. Is your major CS? Yeah, dude. My major, I haven't solved the hard problem. Yeah, I've only really attempted a couple hard problems. I think I've solved like maybe 4 or 5, but definitely a level difference there, man. Is your major CS? Yeah, it is, dude. Yeah, my major's CS. Okay, let's get rid of this. Right. Let's fix this right here. Let's move into this question. Move in here. We need to check if it's hitting a border, right? So what am I missing here? Okay, so what do we want to do here? We want to... So it's saying that we probably need a flag here, like an is closed flag. I think that's is closed true. So we start off saying that it's true, right? We loop through, we pop, we go through our directions array, we add a new row. What we want to do here is we want to do a pre-check here, and we want to check if it's a border. If it's a border, right? If row, it's for Android apps. Yeah, I know what Kotlin is, dude. Yeah, I've looked into Kotlin. You know, I know what it is. Like, I know the language. I know kind of what it's used for, but I've never really programmed in Kotlin before. I've never really touched it. So, I feel like it's tough to get experience and everything, man. Okay, so let's do if row is equal to 0, and row is equal to rows minus 1, and col is equal to 0, and col is equal to cols minus 1, right? This is how we know that it's an edge. How is closed is equal to false. Okay, so we check if it's a border, right? So if we can get to the border, right? I feel like they could have provided better examples, and we know that it's false, right? So we want to return our flag here. Return is closed, right? So when we return is closed, we want to check, well, okay, if this works, then we want to increase our count by 1. And I think this should solve it. Nope, it doesn't. Our output is 6, 12. Okay. If BFS, we're missing something here. If row is equal to 0 and row is equal to rows minus 1, how is closed is equal to false. Okay, they check if it's in bounds here. Return is closed. Oh, it's because it's inside the while. That's why we got that. Whoops. Okay, I think it should. Nope. 2, 3, 1. Inside our while. I'm going to get rid of this queue from here. Just because it's kind of, I don't move this inside. Oh, we need to get rid of it down here. Keep grinding, bro. Going through same path. What year are you in right now? I'm a senior, bro. Hazma. Well, actually, I've technically graduated, bro. So I'm just kind of preparing for the job hunt. So, yeah, I'm just kind of looking for a job right now, and I've already graduated. So I went to Eastern Illinois over here, bro, on the wall. Very, very small school, literally in the middle of Illinois, surrounded by cornfields. I played tennis there and played sports. It was fun. Loved it, dude. I was in a fraternity too. Had a great time. It was some of the best years of my life. So I kind of started on the lead code grind a little late. So I'm kind of trying to just jump straight into it. Okay, let's look at this. Return is closed. Inside the while. I feel like I'm missing something here. I know what's wrong. If row is equal to 0 or row is equal to -1, or we're doing an and, that's why it's not working. I'm getting distracted. I think this is our issue here. Bro, no, it's not. What is our issue here, dude? There's some small ass issue here. I don't know what it is in the code. I definitely know it's some small thing here. We're checking. We have a flag here, right? We're assuming that it's true when we start it. Don't complain to me, bro. I'm literally going to Invisible University in Serbia. Almost 0 US companies know about Serbia's unis. Yeah, bro. Actually, my father's from Croatia, bro. So I'm actually I'm a citizen in Croatia as well. So I can't speak Croatian at all. I wish my dad told me when I was younger, but Serbia is brutal, dude. Serbia's cool, man. Serbia's cool. It's a nice place. I've been there. I played tennis, so I love Djokovic, dude. He's one of my favorite players ever, bro. He kind of inspired me to play tennis when I was younger. I played tennis my whole life and came here on a scholarship to play tennis. So I love the guy, man. Serbia's a cool place though, dude. And you keep grinding too, bro. Like everyone's just gotta grind, man. It's tough. Okay, so I'm checking here. It's the border. Am I fucking anything up here? I don't know. Okay, so if it can get to a border, then you know it's false, right? So if we have all these zeros, we get to a border array, we know that it's false. So I think that would make sense, and we return is closed. But how are we getting 14 here, bro? Like, what? If grid row call and row not in visited. BFS row call visited directions. Do we maybe use a new visited every time? I don't know. No, I don't know. I don't know, dude. I don't know what my bug is. I have to ask GPT what my bug is, man. Your border check inside BFS is incorrect. A cell can't be row is equal to 0. Oh my gosh, dude. This is my error, dude. This is an OR here as well. Right, they can't be both 0 and they can't be both 0 and the last row. So there's our issue. There we go, man. Solve the problem finally, dude. Oh my gosh. Currently all state unis in Serbia are in blockades because of shit government, so I just started with leak code. To me, you are advanced level. Oh, dude, I appreciate it, man. I am not good at leak code whatsoever, bro. Like, I'm pretty garbage, not gonna lie. I think there's like way more cracked people out there. Like, I think I'm still a beginner, man. Do we think the solution? Do we have to think solution like this in a job? No, bro. I don't think so, dude. This is just some bullshit, dude. I actually really enjoy doing leak code, believe it or not. I don't know. I really enjoy it. I think it's fun, to be honest, dude. I've been doing it for like 6 months now, so it's like it would check how many problems I've solved. I've solved 426. There you go. I kind of started doing it last year a little bit. You know, I've been kind of consistent with it. I mean, you can see I don't do it some days, but I've been pretty consistent with it. So usually I'm gone like some weekends and I just can't solve all the problems. Like, I can't do problems. I have a YouTube series like on my YouTube channel. You can see when I first started, like, I was pretty garbage. So it just takes consistency and practice, bro. But yeah. So just keep going, dude. Like, just keep going and just try and have fun with it. Let's go to my problems. Hang on. I've kind of worked through Nicode's. Let's check out Nicode's website. I think I've. Oh, there you go. Oh, okay, it didn't save. You can see I've done kind of his backtracking DP problems, dude. I literally hate DP problems. I struggle with them so hard, bro. Like, you know, it's tough out there, dude. Do we have? Oh shit. Let's jump into another problem. Graph theory. So this one, I did this the other day, man. This one kind of threw me off. I was thinking of Hamilton circuits when I was doing these bar-partie graphs, but really, like, I totally forgot in college when I learned why partie graphs, you have to separate them by colors, and I literally couldn't remember that. So I just wish I could get LeetCode Premium too, bro, because I feel like I'm missing out on some of these problems and kind of pissed me off. I can't do it. Let's check out a problem I've already done. What helps with me too is like doing problems that I've already done. You can see I've done this problem like probably 3 times or whatever, but let's reset this code. Whoops. Okay. There are a total of num courses you have to take, labeled from 0 to num courses -1. You're given an array prerequisites where prerequisites I is equal to AI, BI. In your case, you must take course BI first if you want to take course AI. For example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. Okay, so There are a total of 2 courses to take. To take course 1, you should have finished course 0. So to take course 1, you have to take course 0. Okay. So like the first thing I think about when I think about graph problems, or at least, you know, problems that you have to make an adjacency list, right? So let's create that. Let's pass in our edges. Create a graph. Right. Let's call it. So let's do adjacency list. We pass in our prerequisites. I did this problem about 2 months ago, so let's see if I can kind of think about it the same way. Damn, I tried to set up like a chat like on screen, but it didn't really work for me. I have to kind of figure out how the hell that works. I'm pretty new to this. This is my first time ever streaming in my life, so yeah, anyway. Graph is equal to this. Let's do, okay, graph. Let's print our graph here, right? So really when we loop through this, we want to think about this as a directed graph, right? Because to take course 1, you need to take course 0, right? So we don't want to be able to go back to course 0, right? We need to think about it as a directed graph. So if we were to loop through this, we do for edge in edges, right? So AB is equal to edge. So to take course, we want to do 0 goes to 1. Going to sleep right now. Good luck, bro, and keep grinding. Big companies are waiting for you. By the way, free Palestine. Appreciate it, man. Thank you so much, man. Good night to you too, bro. Just keep grinding, dude. You too as well. You keep grinding too, man. It's definitely a grind. So good luck to you too, bro. Okay, so we want to append graph. Graph B dot append A. Right, because we want to append, this would be our B here. We want to append 1. Right, because we want to start at 0, right? Because 0 is our prerequisite. To take course 0, we need to take course 1, right? So let's do, well, okay, if graph, so we have to check if it's actually there or not. If graph, if A not in graph, and graph A is equal to this, empty. If B not in graph, to graph B is equal to this. We append here. Okay, we don't need to append the other side. We return our graph. Right, so this will be our adjacency list. Pretty much what I'm doing here is kind of just making this like better in a way, or easier to loop over in terms of, well, I'm gonna run a DFS on this, so okay, so that worked out, right? So now pretty much what we got to do here, I think, is we got to start at 0 and we got to loop through, and we got to keep track of our visited set, right? So example, return true if you can finish all courses, right? So if we have our visited set and we can run DFS and get through and visit each node, then I'm pretty sure, I mean, that means you can take all the courses, right? So let's do that. So I guess, oh, whoops, we want to get out of this, my bad. I'm inside of this helper function here. So let's do def DFS, right? We want to pass in our node, our visited, probably like some sort of path or something, right? Okay, so we want to go, okay, so for I guess, can we start from 0 though? That's the thing. Can we go, trying to think here, would we have to loop through each Return true if you can finish all the courses, otherwise return false. The total take level from 0 to num course -1. You're given an array of prerequisites where prerequisites I is equal to A. In case you must take course BI first if you want to take course AI. Right, total of 2 courses, right? There are total 2 courses to take. Take course 1, you should have finished course 0, and to take course 0, you should have finished course 1, so it is impossible. Am I thinking about this the right way, though? To take course 1, you should have finished course 0. Maybe I'm not thinking about it in the right way. You know, I'm not sure, dude. Okay. We have a for loop here. I don't know how I'm meant to think about this problem. Anyone have any ideas, or I don't know. I've solved this problem before, but honestly, I cannot remember how I did it. But trying to think here. Let's go for node in num courses, right? Because we have what is our num courses in this case? We have 2. I in range num courses. We want to go -1, right? We're given a 2. We want to call our DFS function. DFS num courses. Sorry, DFS. We want to pass in our node. Okay, we probably want like probably some sort of visited set, right? Visited is equal to set. DFS node, right? I feel like I'm missing something. Want a visited path. Want a brand new set, right? So this problem is equivalent to finding if a cycle exists in a directed graph. If a cycle exists, no topological ordering exists, and therefore it would be impossible to take all courses. So the great tutorial explained the basics topological sort. Okay, so we're looking for a cycle, right? So that makes a little more sense. If we're looking for a cycle, then we got to loop through every single node, right? So if we're here, okay, we're gonna return probably a boolean. So we want to check, well, if this is true, right? If this is true, right, if we find a cycle, what are we returning here? We're returning a boolean, and we want to return false. Otherwise, I guess we can just return true, right? So if we go through this and we enter the DFS, right? Okay, so if we want to check, okay, well, if node and visited, right? Okay, if we visited this node, then we know it's a cycle, right? So we can instantly just return true, right? We found the cycle. Okay, otherwise we want to loop through. We want to go for neighbor in, that's what I'm missing, our graph. I feel like we don't even need to pass it in anyway, but I don't know. It's whatever, I'll pass it in. It's a parameter. We want to loop through our dictionary, right? If for neighbor and graph node, we want to check, okay, well, if how many programming language you mastered? Dude, I don't think I've mastered any programming languages, bro. I don't even think it's even. Yeah, bro. I've never even worked a job in my life, bro. Like, well, I've done a couple internships, but like, I don't think I've mastered any language, man. I'm kind of just riding along here, dude. I was going to say, I don't even know if it's possible to master a language. I feel like you're always going to be learning something. I've worked with Python, like Java and JS before, but and like JS being like web development and stuff, but I've never really, worked a full-time job and, worked on products or anything. I'm just kind of a student, just working on lead code and stuff. So for neighboring graph node, we want to check, okay, we're looping through the nodes. We want to check. Oh man, I need to fix my hair, dude. Man, this is tough. Okay, we want to check. We want to call our DFS on this neighbor, right? So we call neighbor visited path graph, right? Probably want to add our visited here, right? So visited.add node, right? Because we're looking at that node now, right? Then we loop through the neighbor, call our DFS function again. We run it on our neighbor this time, right? So okay, if the node's in visited, we return true. Okay, so if we return true here, then we just return true. Otherwise, we come down here and we return false, right? This is where I get confused with the DFS part when we're thinking about, like, I feel like you have to keep track of the path as well because you got to free the path, but we're literally just checking for a cycle. Pretty much in this problem, we're just checking for a cycle, and I think this maybe will do it, but let's just see what we get here. Okay, we're missing something here. We're missing a colon. Gotta wait a little bit, man. It's that leak code free leak code life, man. Oh my gosh, dude, did I just solve it, dude? No, there's no way. Key error 0. Okay, well, we're doing something right. So for neighbor in graph node, always getting these key errors, dude. What would be a key error, dude? What does a key error mean? Again, oh, dude, I gotta submit it. What is a key error for neighbor? For neighbor in graph node. What is a key error in Python? I need to refresh myself because when access to a key in dictionary doesn't exist. Since C not in dictionary, Python throws a key error. Check first. How are we getting... Is it because there's nothing in there? I don't know why we're getting a key error here. I assume that it's probably because there's nothing in here. I don't know. Why am I getting a key error here? Why am I getting a key error? You're gonna get key error because you're calling DFS node for every course from 0 to num courses -1, but your graph only contains the courses that appear in the prerequisites list. Oh, okay. So it's an error down here. Throws a key error. For neighboring graph.get. Okay, but why do they use the path here? Path.add, visitor.add node. So they add. Okay, I'm gonna try and do a quick fix here. So they're saying to use .get here. So you get the node. Get the node, or you return an if it's not there and you. So I'm curious, what am I gonna get another key error here, or is this gonna submit? Okay, so it doesn't submit. So why do they use the path here? I gotta think about this. I always get confused with this part in DFS. So if node in path they return true. If node in visited they return false. Path.add node. Okay, so in here they have if node in path. So this is the current path that we're tracking in DFS, right? If node in path, we return true, right? We found a cycle. If node in visited, we return false. But why? So this is our cycle detection here. But why are we checking if node in visited? Visited, we checking turning false. How is your leak code site working, bro? It's down on my side. Dude, I have no idea, bro. I don't know how it's working. I'll try and go to the website again. Yeah, I mean, I can get to the website. I don't know. I have no idea, dude. This is the skip work for nodes we've already fully processed, meaning we've already visited all their descendants, confirmed there's no cycle, and safely marked them as done before adding them to visited. So if we hit that node again later, we just return false, no cycle here without checking again. So pretty much the pretty much the it broke my streak, man. Ah, dude, I'm sorry, bro. Today's daily problem wasn't easy, bro. It wasn't. I mean, I struggled with it, dude. It took me like 45 minutes to do it, but you know, I got there in the end. So, it was a little tricky, dude. Little greedy problem, kind of tricky. Is track nodes correctly. Let's proceed. We skip processing again, but that's where the speed comes in. Okay. So if the node is in path, we return here. We're checking if the node is in visited, right? To kind of speed it up, right? Because visited, we're keeping track of nodes that are that we fully looked at already, right? So that we know that there's no path, there's no cycle within that path. I'll solve it as soon as the website is working. Yeah, dude. You should do that. How many problems you solved on LeetCode, bro? Seems like if you got a streak, you must be doing it for a little bit. If node visited, we return false. Otherwise, we want to add it to our path, right? Loop through our neighbor. If it's true, we do visited.add node. We want to return false, right? we get through here. Oh, we already got our return files. Whoops. 171 problems. Yeah, dude, nice. I've solved not much. 171 problems. That's still a decent amount, dude. I've solved about. I literally just looked at it. I think I've solved about 425. So, something like that. But I don't feel like I'm good at all. Someone in the comments just told me they thought I was good, but I'm definitely I don't think I'm anywhere near good. I think I'm probably average. Takes me a while to learn stuff though. I'm not really a fast thinker. I'm sure you've probably realized as you're watching me do this. I'm not very fast thinker, so that can either probably kind of hurt me or maybe it can help, dude. I don't know, but path.remove node. Why are we removing it here though? Because if we're adding our path, we get here. Why are we removing the path? Issues with me, dude, is I struggle a lot with recursion. You know, I always find it really tough. Like, I don't know what it is, especially DP problems. I'm okay with like kind of normal recursion problems, but like for sure DP problems like kind of get me, dude. It's really hard for me to think about those. Like, I feel like I'm best at like BFS, DFS, you know, tree problems, graph problems, you know, stacks, queues, you know, whatever you name it, linked lists, like arrays, you know, sliding window. I kind of struggle a lot with binary search too. I find it hard to kind of think about binary search, but definitely DP problems are the toughest ones for me. So, what about you? What about you, Somya? How do you? What are you good at? So when we're done exploring the nodes, think of a path as an active VS Code segment. You're done with the node. It's not. We are looping through num courses. Each core DFS represents a new independent DFS traversal starting from that course because the graph may be disconnected. Oh, okay. Okay, let's see what we're looking at here. Have we solved it now? Path.remove. Let's. Graphs and DP is still left on my side. Oh, there you go. Submitted it. Problem solving ability isn't defined. Number of questions you solve, but how well you recognize and apply the patterns. Yeah, bro. I agree with that. I would say probably DP is definitely the hardest. I feel like I've encountered. For sure. I mean, I still struggle with it, but yeah, I don't know, dude. You know, man, I've solved about 400 problems, and I try to keep going, but you know, whatever I get on the technical interviews, you know, whatever problem that they give me, like, you know, I'm gonna try my best to solve it, but I just try and just keep going every day, bro, and do a couple hours every day, and just keep going. So that's the goal. I'm gonna have a look at what I submitted back in April. Actually, let's look at April 21st. Show me my solution, bro. Okay, we did it kind of the opposite way here, but okay, we're gonna move on from graph problems, dude. I'm done doing DFS and BFS. Are you Samir, are you still a student, bro, or have you graduated? Uh, okay, let's jump into a study plan. What do we want to do, man? Dynamic programming, DP, code 75, top 100 like problems. Top 100 best rated problems, man. Maybe we should jump into that. I don't know. 30 days of pandas. You're a student, dude. That's cool, man. In 4th year of college. Nice, bro. Good on you, dude. I hope the best for you too, bro. Like, keep grinding, dude. Keep working on those. Keep working on the problems, dude. I'm sure you're gonna go. I'm sure you're gonna go far if you have that consistency. I feel like that's the most important thing. See, bro, binary search, man. Dude, it kind of makes me binary search kind of makes me want to throw up a little bit. Not gonna lie, but got some backtracking, dude. DP. See, I've done a decent amount of DP problems here. Graph, hashing. Dude, I've literally done like all of these problems. Like, see, let's take a look at N Queens, dude. I feel like this is a classic problem. I've never even looked at this problem, so this is gonna be tough. N Queens puzzle is a problem placing N Queens on an N times N chessboard such that no queens attack each other. Given an integer N, this is kind of like chess, dude. I like playing chess. Given an integer N, return all distinct solutions to the N Queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration of the N Queens placement, where Q and dot both indicate a queen and an empty space, respectively. Okay, so trying to think here. Backtracking problem, N Queens, a classic problem. I've sent you the list on Instagram, dude. Honestly speaking, binary search is only a combination of 15 patterns. Combination of 15 patterns. Yeah, that is true. I just feel like it's hard, like with binary search, it's hard to like, you know, like for example, just kind of like implementing binary search on like a normal like list of numbers, right? And you're trying to find a specific number is a lot different. Like it's like very easy, right? But to apply it on like, for some reason, bro, cocoa eating bananas, dude, that question like drives me insane. Like, I don't know what it is, but to apply binary search on a question like cocoa eating bananas is like really hard for me to think about. Like, I literally might be stupid. I don't know. Like, maybe I'm stupid. Like, I feel like I'm a really like average person when it comes to problem solving on LeetCode. Like, I'm very average, but you know, to apply binary search on a problem like that, where you have to think differently in terms of the binary search, think about like, you know, how you use the low and the high and how to apply it on that specific sort of problem is like very, very tough. Like, at least to me it is, you know, and I'm not cracked or anything. I'm like the most average dude out there again. So it's definitely very tough. Like, there exist two distinct solutions to the N4 Queens puzzle as shown above. Okay, so what are we returning here? We're returning a list and a list. I'm confused what we're returning here. The N Queens puzzle is probably placing N Queens on N times N chessboard. Oh, okay. So we're looking how many queens we can apply on this board. Okay. I thought we were checking like, you know, if any of them are hitting each other or something, but okay. So we have to actually return the board. Okay. How to approach this problem? I got no idea, to be honest. Have you solved this problem, Samya? You solved N Queens, bro? I've never even looked at this problem before, so let's take a look at some of the hints, man. I feel like, oh, there's no hints. All right, okay. The king is getting smart. None of his queens could see each other. He could go and see anyone. There exist two distinct solutions to the 4 queens puzzle as shown above. Okay. How do we want to think about this problem? Well, we got a 4x4 board, right? We know that Nope. Yeah. I know this one's on the netcode 150, but I never solved it. I never looked at it, so well, I feel like you would want to check each queen you want to place, right? Is if there is a queen already in the board, right? Either going right or left, then you can't really add one, right? So technically, my thought process here. Let's get rid of this shit. So let's say we have a 4x4 board here, right? This is gonna be a terrible drawing, dude. Oh my gosh. Right? I'm gonna try and draw this like perfectly for you guys. I feel like my drawing skills are probably terrible, but okay. Tell me what you guys think about this, because I literally I don't know if this is right. It could be, but to be honest, now that I think about it, I'm not really thinking about it in a backtracking way. Okay, we're gonna make our queen red, right? So we start off with an empty board, right? And we start off at this square, right? We can add a queen here, right? Because we know that there's no queen in this row and there's no queen here, right? Then we go here. We check, okay, everything in this row, right? There's a queen in this row, so we don't add it. There's a queen in this row, so we don't add it. There's a queen in this row, so we don't add it. We come down here. There's a queen in this row, so we don't add it, but then there's a queen here. But then the queen can hit diagonally, so that's not going to work, right? So that doesn't work there. But so somehow we'd have to check the diagonals too, right? But I don't know. I don't know how to solve this. Cross the magic of the backtracking before you fully understand it after this problem. It's not daunting as it may seem, especially if you tackle plenty of BFS, DFS problems before. It's when you finally fully understand something new that you have been elusive for a long time. Yeah. I forget the diagonal. Trying to think here. So we can place a queen. You know, I'm just gonna watch netcode's video, dude. And queens netcode. Let's take a look at his video. Because I need to look at something.
If working with AWS Cloud is your job, then you need the ultimate AWS certified cloud course on Udemy. These video lectures and practice activities can help you upskill your team and prepare for your AWS certification. And because Udemy courses are taught by real-world experts.
Hey everyone, welcome back, and let's write some more neat code today.
So kind of how to apply it in terms of the thinking, but I do struggle a lot with backtracking problems. Well, recursive problems in general. So let's take a look.
Today, let's solve n queens. So this is a pretty famous.
You guys probably don't want to jump on here and watch netcode, but I feel like it's important for me, so I need it.
This is marked as a hard problem. Super hard to come up with what the solution would be, at least to come up with how to solve the problem. I think the hard part about this is actually implementing the code of this problem. Because like I said, it's backtracking, so basically we're just going to be doing a brute force approach. So the problem statement is we're given n queens, we're given a board of size n by n, a chessboard, right? So the dimensions are n by n, and we're also given n different queens that we have to place somewhere on this board such that no two queens ever attack each other. So you have to know a little bit about chess. So
I feel like you could easily solve this using backtracking, right? You could place one and brute force it, right? But I I don't understand how you'd probably check the diagonals. Like, that's the tough part.
A queen can move is that a queen is allowed to move in any direction horizontally, so it can move to the left or to the right. It can move up or down, so it can move in all 4 directions. It can also move diagonally, so you know, this diagonal, which I call the positive diagonal, because you can see it's kind of a positive slope, right, top right. Also, it can move in the negative diagonal direction, which you know, you can kind of tell is going bottom right. So it can move in these different directions, and that's kind of what makes it tricky. So we want to place the queens in such a way that they don't attack each other. So right now you can see this queen is going left, right, top, bottom, this diagonal, and this diagonal, right? So it's definitely not attacking any other queen. This queen as well, you can see it's going up, left, right, down, diagonal, and you could do that with all of the queens, right? I don't want to make it too messy though. And then what we want to return is actually these boards themselves. So in this case, we were given n equals 4, and you can see that these 2 different compositions are the ways we could arrange the queens, and then we want to return that as a list of strings. Each string represents 1 row in this board. Now, the main thing you notice initially is, okay, since a queen can go horizontally or vertically, therefore, every queen has to be in a different
we
row,
thought about this,
right?
like we
notice how every single queen is in a different row. That makes sense, because if we ever put 2 queens in the same row, then
we knew this part. Sorry, Solo. You cannot put 2 queens on the same row, so you have to go forward to the next row and try to put the queen there if that is possible. I agree. So I kind of thought about that earlier, but what I don't understand is how you kind of do the diagonal. That's the tough part for me.
They'd be able to attack each other, right? So each queen
to kind of figure
has
that
to
out.
go in a different row. Notice how each queen is also going in a different column, right? Each queen, in this case, is in a separate column because they can move vertically. We don't want them to attack each other vertically as well. So that's pretty straightforward, I think, but the hard part is diagonals, right?
Here we go.
Notice how
diagonals
we
here.
have many different diagonals in this board. Let's just look at the positive diagonals, what I call the positive diagonals, the ones that can go top to right. So notice how, in this case, we have many different diagonals, and in each of the cases, each queen is in a separate positive diagonal, right? You can see that that's the case. What about negative diagonals? Okay, this is one negative diagonal, this is another. Each queen is in a separate negative diagonal because we don't want any queens to attack each other diagonally. So this is going to be the part that's a little bit tricky to code, at least until you've seen it before, but it's actually really easy to implement once you know the main idea. So now let me kind of show you how we're going to apply backtracking to this solution, how we're going to apply the brute force method to get each valid arrangement of the n queens. So what really
it's crazy.
Ryan Miller invests the way
might have is, okay, let's just choose, okay, we can pick any of these positions in the 4x4 grid. Let's put a queen over here. So that's the first position we try. Okay, now let's try a different position, right? For the second queen, let's try putting the queen in this position, right? And then now we have all these remaining choices. Let's keep putting a queen in every single position and trying that. So this is one arrangement, then maybe we could take the fourth queen and put it over here, etc., etc. Now, why is there any reason to do that? That's a little bit too brute force if you ask me. There's a much simpler way we can do it, right? Because for each queen, instead of having n squared choices, how about we just have n choices, because we know for sure each queen is definitely going to be in a different row. So first we can go like this. We can say, okay, we can decide to put, for this first row itself, right? This first row, we can decide to put the queen in the first position, or we could decide to put the queen in the second position, or the third position, or the fourth position. Whatever we do in that first row, then we're going to move to the next row, right? So now our goal is to find a different location where we can put the second queen in this second row. Now we could try putting it over here, or we could try putting it over here, or we could try putting it over here, but we can't put it over here. Why is it that we can't put it here? Because they're in the same column. So
Okay.
now you already can tell we're going to need to be maintaining the columns of whatever previous queens that we have already placed. We don't have to maintain the rows though, right? Because I just showed you why. Because every time we place a queen, we're going to move to the next row anyway until we get to the bottom, right? And then we're going to make sure that we're placing the last queen in a valid location, and if we are, then we're done, right? So we are going to have to keep track of which columns we place a queen in, and we're going to have to keep track of the positive diagonals that we're placing a queen in, and we're going to have to keep track of the negative diagonals that we're placing a queen in. And we can keep track of all of these with a set, right? So a set can tell us, a hash set can tell us which column of 0, 1, 2, or 3 we have put a queen already in, and we can do the same for a positive diagonal and a negative diagonal. But I bet you're wondering, how can we do it easily with positive and negative diagonals, right? We don't have indices for something like this, right? What index does this diagonal belong to? What index does this diagonal belong to? And I'll show you there's a bit of a pattern when it comes to diagonals, positive and negative diagonals. Let's say we start at the origin, the top left position, and then we go diagonally bottom right. So this is what I'm going to refer to as a negative diagonal, because from left to right, we'll end up going downwards, right? Do you notice anything about this diagonal? Well, we're starting at 0, 0, right? The row and column are 0, 0. As we move diagonally down, we get to this position, right? Then the row and column are 1, 1. Then we get to this position where the row and column are 2, 2. So notice how each time we're increasing the column value by 1, and we're increasing the row value by 1 as well. What does that tell us? That tells us along this diagonal, along this negative diagonal, the computation row minus column is going to stay constant. Over here, right, in this position, if you take the row minus the column, we get 0 minus 0. That equals 0. If you take the row minus column in this position, we get 2 minus 2. That equals 0. So we can define this particular negative diagonal as being the 0 negative diagonal. Let's try it out on a different negative diagonal to see if our pattern holds. Let's start over here at a different position, row 0. How whenever we're going negatively diagonal, we're increasing the column by 1, and we're increasing.
This problem is difficult, bro. As well, I saw that you can use these dots here, but so I think the way we want to look at it is we probably want like a backtracking function, right? We probably want some sort of like save function, right? Like checking to see if the queen we place is valid, right? I feel like the backtracking function is pretty simple to implement, but just checking to see if it's safe is I feel like is kind of the hard part. Okay, let's create our result, right? We need some sort of like list comprehension here, right? So, man, I don't remember how to do it in Python. List comprehension, Python. So pretty much I just want to fill this board with dots, I feel like, to begin with, right? So for dot, not for, and I'm in literal if condition. In iterable top for I in I in what we do I in n oh shit, yeah, times n for in result. Is that right? No, in dot times n, so times for something in maybe it's range n. I don't know. For diagonal, you can use absolute function. Appreciate that, bro. To be honest, this problem is gonna take me a little while to do, bro. Let me just set it up properly. Let's take a look at our board. Hopefully this works. Invalid syntax. What am I missing here? Times n for something. What is wrong here, dude? Oh, this has to be a string. I think that's why. Okay, here we go. Okay. Okay. We're getting somewhere. Man. So how do we want to do this, right? When we backtrack, we want to go by row, right? So we want to place something in the row. That's what decode said in the video. We want to backtrack by row, right? So I feel like we're going to need some sort of backtracking function, right? Backtrack row. Probably going to need some sort of function here, like, I don't know, is safe, right? This helper function, check safe, right? Probably backtrack 0, right? Let's return our res just for now. Okay. How do we want to do this backtracking function? So you want to pick somewhere to place a queen, right? I'm gonna have to search up. I don't really understand like how I'm gonna solve this problem. So I don't feel like I can. Queens leak code. I don't really feel like I know how to solve it. I don't want to watch a video there. King queens class problem that can be used solely backtracking the goals place and chess square queens on n times a chessboard such that no queens threaten each other, meaning no two queens can each call can only one queen dice can. Start by placing a queen in the first row, first call. Okay, if the placement is safe, doesn't conflict with previously placed queens, mark the position as occupied and recursively try placing the next queen in the next row. Okay. Placement leads to a conflict. Backtrack to the previous row, try a different call. Okay. And you can track the queens you have up to now in an array. You can track the queens you have insert up to now in an array. Okay. How do I place it in here though? We got a row, we pass in our row, so we're looking at the current row, right? So for call in range n, then we can place our queen, right? So we would go, what are we looking at? Board, row, call is equal to queen, right? Is that what we're doing? Capital Q for queen. Okay. Right, so we place a queen. Then we want to check, is it safe, right? I feel like that's probably, so is safe. We probably want row call, right? Call in range and board row queen. Do we want to check that it's safe? Is that how we want to do it? Check that it's safe as soon as we place our queen? Maybe we can check it before. We can go like, if is safe, row call. We can go board row call is equal to queen. Then we backtrack to our next row. After the, you can track the queens you have insert up to an array. Okay, after the check, it is, if it is safe, you can call backtracking function. Okay, I mean that's what I just did. So if it's safe, row call, we place our queen, we backtrack the row, right? I guess we need an exit function here, right? So if n is equal to, sorry, if row is equal to n, we want to exit, right? We want to return, we want to make result is equal to, we need some sort of list comprehension here at the end, and I struggle with list comprehension. No. If row is equal to n, we go, let's just do like a res.append here, right? Let's just leave that for later, right? We backtrack row plus 1. We know that's safe. Is that it, right? If not, we might want to Linux Mint user. Yeah, bro. Linux Mint, dude. I just actually switched to Linux like a couple months ago. So I actually love it, dude. I never thought I'd love Linux, but I do. I love it. So yeah, it's goated, dude. Board row call. Where's the backtracking part though? For call in range n, if is safe, row call, board row call is equal to queen. We increment. Backtrack So we're looping through the coals here. We're checking if it's safe. We're adding the queen. We're backtracking. So we're checking. If it's not, we come back and we make it a dot. You have to find a solution where you have placed the maximum of queens, which is 4 times 4 measures, so that is the base case. Yeah. So I think this works. So now we got to write, I think this is correct. So now we got to do our save function, right? So how do we want to do this? Well, we want to check, we need to check the row, the column, and then we need to check the diagonal, right? So row, col, diagonal, right? So how can we check the row? Well, okay. For I in range, I guess we need to pass in our row and our col here. For I in range col, if I is equal to queen, we want to return false, right? Because if we're passing in here, we loop through our cols, check if I is queen, we return false. Sorry, we need to do, well, board row I, whoops. What am I doing here? Is equal to queen, we return false. We know our row's fine because we checked if it's safe here. We're doing the rows here, so I don't think we actually need to do the row. You don't need to check the row because it's impossible to have 2 queens in a row because you have, yeah. That's what I just kind of thought about myself, right? We're doing the row here, right? So technically we just need to check the column, right? So we go for I in range column. If board row I is equal to queen, we return false. Right? And now we got to check the diagonal. I got no idea how to do the diagonal, bro. So if you can help me here, dude, I've got absolutely no idea. Like, I know he was talking about it in this video, but to be honest, I was kind of half paying attention when I was watching it. So, I know he talked about 2 sets, right? So we need like a pos diag set and we need a neg diag sec. That's what I did hear about in the video, but I don't know. I feel like can you use like a directions array, like kind of what I did in BFS, by like looping through that directions array and just checking everything? I don't know. Like, for example, if I was to make a directions array here, I don't know if this maybe could be a better way to do it. I don't know. Right? We can do all the diagonals, right? So we can do diag top left, diag top right, diag bottom left, diag bottom right. What do you think about this? What do you think about this solo, right? I go through here, right? To do the diagonal top left, right, you would go, let's say we're looking here, we would go up 1, left 1. So we would go up 1, which would be -1 on the Y, and then boss. Thank you, Marika, boss. Appreciate that, bro. We go -1, -1 here. and we go, so that would do the top left, right? Think about going up in the Y would be -1, going left would be -1 again. So then I think if you go top right, it would be -1 here, then a 1, right? Then to go bottom left, we would have to go -1. To go diag bottom left, we would go be a +1 on the Y. Bottom left, to go left, we would go -1, right? Then we would go 1, 1. So then we could do 4 new row, new call in directions. Maybe this is a terrible way to do it, dude. I don't know. I mean, this is probably an n squared. I don't know. I don't know if it would accept this, but I don't know. Fuck it, we'll try. We do new row is equal to nr plus row. New call is equal to nc plus call. Right, and then we check. We obviously have to check if it's in bounds. If 0 is less than or equal to man, someone's calling me, dude. Appreciate that, OX80, dude. Good luck to you too, man. Do you post stuff on the internet, bro? I'd love to see your stuff, dude. But good luck to you as well. This isn't gonna work, actually, now that I think about it. Because we need a way to save what we've looked at. I don't know how to do this here, dude. I think I'm doing it wrong here, dude. I don't know if this is gonna work. I don't think it can work. I think we're doing this wrong. I think it's supposed to be the other way around, actually. For new row directions, new row, new call. I mean, it's gonna check these other ones, but how would we keep going? Maybe can we just use a Q here or something? Maybe, I don't know. Like EQ. Check bounds and use Q. I don't know. Maybe we can do kind of like a BFS sort of thing. Would this work? Would this work for 51 and queens? While loops to walk along the diagonals. Okay. Yeah, why didn't I think about that? Diagonal. While loop to walk along diagonals. Right, so how would we do that? How would we check the diagonals like this? well, maybe we'd have to go... Well, we can't check the diagonal from the spot that we're looking at, right? If we place a queen here, we can't check like this, right? Because then we'd have to go both ways, right? So I think the way to check it is we loop... We check up here, and we go up here. Would that work? No. Right? Is that? We check all the diagonals. We can go from here, move to the left, go to here, go to here, and then check here, go to here, go to here. Okay. So I think we have to go top left. Right, so to go to the top left, we have to make, well, row is equal to 0. Right? Col is equal to 0. I think this is the way we want to do it. Then we would go... Maybe not, actually. We could do... No, actually, let's do... We'll make row is equal to n minus 1. Col is equal to n minus 1. While row is greater than or equal to 0. And col is greater than or equal to 0. Okay, n minus 1 is down here, right? So what would here be? The left diagonal. It would be... Let's do... This is bottom right. Okay. We'd obviously want to check our bottom left, right? So our row would be equal to n minus 1. And our col would be equal to 0. Right? While our row is greater than or equal to 0 and our col is greater than or equal to 0, we want to check, well, if just checked your GitHub repo for the leak code, doing an amazing job, got a star from me. Appreciate that, dude. Thank you, man. Appreciate that, bro. How many days have you done in your machine learning journey? Or each week? You document my journey studying machine learning each week. How many weeks you done? Appreciate that though, bro. I don't have much on my GitHub. A lot of my stuff is private, but I've worked on a few projects, like not a lot of stuff. I mean, I'm just a student, so I've worked a lot. You know, I just worked on a bunch of CRUD applications, a lot of web applications. I mean, it's most of projects that I've done with like a database and, you know, all that sort of stuff. Simple CRUD apps. A lot with APIs, built chatbots, you know, stuff like that. So don't have a lot of experience, but trying to get more, trying to find the time to do more projects. But it's tough, man. It's tough working a job and everything and going to school and, you know, working on leak code and everything. I feel like there's a lot to be asked about, so it's tough. Okay, so while row col is equal to this, we want to check, okay, well, if grid row col is equal to row, sorry, the board. How do we do this, right? Because we're not really keeping track of where we're doing it. We're just going to the top. Okay, I guess that doesn't really matter actually. If board row col is equal to a queen, and we just simply want to return false, and then we want to update, right? So if we're looking at, we're at the bottom right here, we want to do -1 +1, right? So it would be, I think, row plus or equal to 1. This could be wrong, dude. I don't know. Row plus or equal to 1. Sorry, we want to go up, right? So it would be, I think this would be col. And our row would be minus or equal to 1. I think that's right. So I think that works for the bottom right. Now the bottom left, we're starting at row n-1, and our col is 0. Right? I think that should work. Then we go, well, while row is greater than or equal to 0, do you go to school or university? Oh, sorry, user. I didn't see that you use Arch. I was actually interested in using Arch as well, bro, but I'm not like a Linux bro yet, dude. So, I'm not on that level for Arch yet, but I'd love to switch there one day. Do you go to school or university? Yeah, I do. I actually just graduated. I went to EIU, so Eastern Illinois. Very small school in Illinois. To check the diagonal, you can use A for all your queens you placed. For queen, it's column queen. You have to put current column where you are. Appreciate that, Solo. I think I've kind of got it here. I think I'm just using a simple while loop starting in the corners here and checking shit, am I doing this right now? I think about it. I'm trying to use a while loop here to check all the check the diagonals, but I don't know if this is 100% correct or not. I think it is, but I don't know, dude. I don't know. We're gonna go with it, and then we'll edit it later. And our col, so our col is 0, and our col is less than or equal to where queens is a rate of queen you have up to that moment. Thank you, bro. Thank you for that. Col is less than or equal to. I've definitely done something wrong here, I feel like, but it's alright. Let's do where col is equal to n-1. We do the same thing. We check if it's a row col. It's a queen. We return false. Otherwise, our row. So our row is currently, we're looking at down here. While our row is n-1, we want to go here. So I think we need to go row plus 1. Col minus or equal to 1? I feel like this is wrong as well. Otherwise we can return true, right? So this is our, there's definitely something wrong here, dude, like 100%. Okay, now we have to do the exit here, right? So we would do res.append. I feel like we'd have to do, we can just do for I was going to use a simple double 4 here, but so if the row is equal to n, Um, for I in board. So basically what solo info was saying is you get the x and y distance of the queen to the current row slash column, and if they equal, that means that it's the diagonal. Get the x and y distance of the queen. Trying to think here. Of the queen to the current row. I appreciate it, guys. I know this is wrong, like for sure. I feel like I need to look more in depth in it because I'm a really slow learner, so doing shit like this is just like let's just do result append dot join for R in board. Let's just see if this runs, dude. Don't forget if you can. Yeah, I know. Appreciate that, Dio. I've been doing problems for about 3 hours now, so I'm probably gonna jump off in a second. This index is out of range. So we're not in range. I know this is wrong here, so you're attempting to check the bottom right and bottom left diagonals starting from the bottom row, but your logic is off. You don't need to check bottom diagonals in all and n queens backtracking solution. Bottom left check. Okay, yeah. Your n queens only need to check the same column, the top left diagonal, the top right diagonal. Because the queens are placed one row at a time, top down, there's no need to check the bottom directions. Those rows haven't been filled yet. Sorry guys, I appreciate Dio and Solo. Thank you for all the thank you for the comments, dude. It's hard for me to read your guys' comments and apply it because I'm kind of trying to think in my head like kind of how to apply this and how to think about it. And I don't know, it's tough. Like it's tough. I feel like it's a learning process, and you know, I just gotta kind of make it click in my own head because it's tough to kind of think about that in a way. So appreciate that. I really appreciate you guys helping me though. So thank you. Please keep doing it. In Queen's array, you have to put one first position, the index of the column where you put the first queen. In Queen's array, you have to put on one first position, the index of the column where you put the first queen, for example. Sorry, Solo. I think I'm just kind of cooked, bro. Like literally, too much leak code, bro. Too much coding. I put it into, I just put it into GPT just to see where I was going wrong here. They're saying to check the top left diagonal, right? So the top left diagonal. Oh, okay. I understand where you guys are coming from. Okay, right. I'm thinking about it like going from the top up here, right? But you guys, I think what you guys are trying to tell me is that you need to go from the diagonal next to it, right? The square diagonally from it, either the top left or the top right. Top left, top right diagonal. Because right. Okay, yeah, I understand. You don't need to check the bottom because we're going by row, right? So you don't, if we're going down by row, then you know that these are going to be totally fine. So really all you have to check is the top two diagonals. Is that what you guys were saying the whole time? Solo and Dia? Right, because if I'm going by row, okay, right, I'm going by row, adding a queen by row, right, and then checking if it's safe where I'm adding it. Everything below it is always going to be safe, right? So what I need to do is I need to check the diagonals top left and top right, right? So we check top left here. Let me know if that's what you guys are saying. Sorry, I couldn't really. It just kind of clicked in my head, like top left, right? So to check the top left of our current run that we're at, we want to go row is equal to row -1 would go up. And then, no, sorry, it'd be row +1. Wait, no, it would be row -1. Row -1, this would be col +1. Col +1, row -1, col +1. We check here. Check if it's support. Let's actually greater than 0, right? So that'd be fine. Row's false. To keep going, we need to do row -1, col +1. Wait. No, we're going up, so this would be minus as well. Yeah, why are we going plus? This should be a minus. Okay. So then we go top right. How would you rate your knowledge now? I feel like I feel like I'm average, you know. I don't think I'm anything special or anything, but I'm a pretty average guy. I've gone through Netcode's 150. I'd probably say about 80% of the problems. I've solved about 400 problems. I feel like I can identify patterns very easily. Sometimes it's like, you know, for example, this problem, I've never really looked at this problem before, so, you know, obviously I knew it was a backtracking problem. I kind of knew how to apply it, but it's just tough to get the nitty gritty down. And I'm a slow thinker too, as, you know, if you've been watching a little bit, you can tell I think very slow. So, yeah, I feel like my knowledge is okay, pretty average. I've been doing LeetCode for about 5-6 months probably. So, let's do, okay, so if we want to check our top right, then we would go, our R would be row plus or equal to 1, then row minus or equal to 1. Right, so if our row greater than n minus 1 and our col's always going down, so our col will be greater than or equal to 0. Our row, we're technically going left. Oh no, I feel like our row would be the same. Right? So No, yeah, appreciate that. Appreciate that, Dio. It's taken me a little bit to do it, but it's all right. So let's do coal -1. I think I'm nearly there, to be honest. I just need to get this one down. Coal is equal. Let's do CR. Let's do. Okay, let me think about this more. I'm a slow thinker, so I need to think about this more. So we're here. We want right. So we're going -1 in coal, right? So we know coal is -1, right? We're going this way. Okay, so our coal's going up, right? C is equal to coal -1, while C, I forgot to change these here, R and C. Okay, we want to check, so I know this is the one, our row, greater than or equal to 0. I think it's 0.2 as well, right? Then here we would go plus or equal to 1, minus or equal to 1. We would return true. Are we in bounds now? Okay, we got an infinite loop now. Okay, so we fuck something up. I fucked something up in this problem. I've got an infinite loop in here somewhere. Equal to 0. RC. Is that false? You guys know where my infinite loop is at? I don't know. I know it's here somewhere. I think this one's correct. This just looks right to me, right? Going top right, so we would go for a +1. I think this is the wrong way around. I think we need a plus here and a minus here. A minus here and a plus here. If you use a matrix variable, you could... Great, I got another fucking... -1. Ah, man, jeez. Okay, well, for adding coal, this needs to be changed. C is less than or equal to n-1. Another freaking infinite loop, dude. Oh my god. Bro, this is driving me insane, dude. Oh my gosh, dude. I know I'm so close, man. Jeez, dude. Let's see where I'm going wrong here. Where's the infinite? But after backtracking, you have to reset the matrix. For example, backtracking. Oh shit! I didn't think about that, Sola. Oh shit, I'm increasing RNC here. That was my issue, dude. Oh my god. It's always the little things, man. Okay. So you have to delete the changes you made before. I am deleting the changes I made before here, bro. I'm backtracking here. Is that what you're talking about, or? Killer Gaming. This is Python, dude. Oh shit. Let's just see if this submits. I got no idea. Holy shit, it just submitted. No way. Yeah, I'm backtracking here, Solo. I think that's what you're talking about here, where you say delete the change you did before. Okay, this is okay. Okay. Holy shit, man. That problem took like over an hour, dude. Oh my gosh. That was so confusing, dude. Jeez. Well, we did it. I think I'm gonna call it there for today. I appreciate everyone stopping by and all the nice comments. So thank you guys. I'm gonna stream again. I'm gonna stream every day, so I'm probably gonna stream at this time every single day. So if you guys wanna, join in and help me and code along, it's always nice to respond to some messages. Thank you for being super positive, and I wish you guys all good luck. So thank you guys so much, and I'll see you guys tomorrow.